Last section we finished chapter 6, which was about series. But again, our main objective in this course is to learn how to solve differential equations. So the method that we learned last lecture, it was series solution around ordinary points. And again, because these ones are methods and we are learning methods, it means that the same method cannot be applied to all types of differential equations. So the series has limitation to having it as linear, plus to have P and Q as well analytic at a certain point that we are finding its series solution around it. For today's section, we'll start with a new method, and this new method is called Laplace transform. In order to understand this section, we need the basic integration formulas, and we need also partial fraction. I remember that I went through partial fraction in one of our solving sessions. In case needed, we can recall it also better. We are in the last learning outcome, which is to solve linear differential equations using Laplace transform. And our main objective is to understand Laplace transform plus the inverse Laplace transform, to apply them to solve ordinary differential equations. Now, from its name, Laplace transform, the name of a person, basically the researcher that found this method. But transform, what do you mean by that? When you say transform, what are you doing exactly?
Change element of ordinary equation to equation.
We are applying it to an ordinary differential equation to change into something, just an equation, a linear equation instead. So we'll not have any more variables. But Laplace transform, when we say transform in math, it means that you are having a variable and transforming it into another variable. The most important transforms that we need, they are the linear ones. What do we mean by linear? Let's say the integral. When you are saying integral of f plus g is equal to what? Integral f plus integral g. So we say the integral. And when we say integral of 2 times f, we put the 2 outside. So because of that, we call it linear. Okay, so we'll start first with Laplace transform. After making sure that we understood the Laplace transform, we will discuss the inverse Laplace transform, give examples, and then apply it to it. Okay, Laplace transform, we have a function in T. So in this way, we have a function in T. Okay. But to apply it, there is also a restriction. T should be what? Greater than 0. It means that the function should be defined from 0 to infinity. Okay, miss? If it's defined just from 0 to 1, we cannot apply the Laplace transform for it. If it is defined from over the set of real numbers, we cannot apply this transform. Okay, is it the first transform that we took? Did you take Fourier transform in signals and setting? In one of your electronic courses or communication? Not yet. Okay. So this f of t, we will transform it into, we will apply LT. LT means that Laplace transform. From t, instead of t, we will have s. But it doesn't mean that I will remove t and just put s. One that we will apply is this one. The f of t is given, you will multiply it by e negative st and differentiate with respect to t. From where will we get the s? We are integrating with respect to t and substituting the boundaries for t. So as it's kept the same as a constant with respect to t. Okay, miss? So this formula will apply it for more than one function, and then we will explain other things. Please write the formula. same formula. In order to make sure that we understood it best, let's give a direct example. Laplace of 1. So what's f of t in this case, Miss? Please, all of you should write this. We need to find Laplace of 1. So what's the first step? Equal integral from 0 to infinity, right? What's f of t? And what should we multiply it by? E minus ft d. Remember, we are multiplying, we are integrating with respect to which variable? T. So what did we get here? We got okay. Use this formula to know the integral of this.
1 over plus
1 over negative x, so all of us agree. E minus, right? We cannot evaluate something at infinity. Whenever we say we see infinity, it means that we are splitting limit, okay? So what we used to do in calculus, you put here E, and you put limit, B tends to infinity. This is what we used to do, okay? But in our mind, when I tell you e power negative infinity, let's say you know that this is the limit as t tends to infinity. Okay, miss? So let's write, what will we get now? 1 over negative 1 over x, e minus b minus e minus x, right? Thanks. E power 0 is equal to e power negative infinity tends to what?
1 over
1 over e infinity, which is 0. Now, e power negative infinity, I don't mean that we are putting negative infinity. This is the limit at e power x as x tends to negative infinity. Okay? So what do we have here, miss? 1,
0.
0, right? And this one that is here,
1.
minus 1. Okay? Now, s is positive, s and t are positive. So what will we get? Negative 1 over s times negative 1, what did we get? 1 over s. Okay,
What's the symbol that beginning of question?
Laplace.
You need to look at this right just then.
You can write just now. Again, the other questions, I will put e power negative infinity, but we know that I'm not saying evaluate e at infinity, we are saying limit. But for simplicity, I will write e power negative infinity. Okay, so I will stop writing limit and these ones, but when we say e power negative infinity, we know in our minds that it is limit. So this will be again. We transform one to 1 over s onto Laplace transformation. Right, miss? What's here instead of Laplace of 1, we have Laplace of pi. Please write Laplace of pi. We need to find Laplace of pi. Start it with your colleague and check what will be the answer. Laplace of pi. Pi the constant pi. You can do it in personals. Let's say for around 2 minutes to do it. And of 1, what will we put, miss? Pi. So instead of 1, we will put pi. Here, what will we put? Pi. This pi can you put outside? Okay. So we will get here pi, 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 and what will be the answer? We should get the answer pi over s, right? So in general, miss, Laplace of a constant is constant over s. So when we have constant, this constant, it will be going to constant over s under Laplace transformation. Does it make sense, miss? When you finish taking this notice, please find Laplace of t. So instead of 1 or instead of 2 or instead of a, we would put t. Laplace of t. Please, I need to find this one. Laplace of t. Okay. And if I'm telling you Laplace of 5, it will be what? 5 over s. Now, the next step, I need from each two together to find Laplace of t. There is a homework about series. We have to finish it by Sunday. It's simple. It's only 4 small questions. And I put also a homework. I think it will be available in 2 days about Laplace. But we have time for it. At this moment, you cannot complete it. There is a file, and it is SDQ. You will go to the file, and each question you will choose this SDQ. But don't complete it right now. You will not get it correct because we will not finish. The homeworks are on Blackboard. So the next step, what did we say, miss? We want to find Laplace of t, right, miss? So how do we start? Laplace of t is the function times e minus st dt from 0 to infinity, right, miss? What's our variable here? T, because we are integrating with respect to t. Miss, we have polynomial and we have exponential. This one we can handle that using integration by parts, or an easier way that we learned during the beginning of the semester, tabular integration. So I will do it on the board using tabular integration. We put here the polynomial because it reaches 0, and here we put e minus st the integral of it, and then the integral. So here we are applying tabular integration. Then what do we put here? Plus, minus. What will be the integral now, Miss? E minus t over s, e minus st, minus 1 over s squared, e minus t between 0 and infinity. Again, it's not between 0 and infinity. This infinity we are getting by its limit as it tends to infinity. Any questions so far, Miss? Do we have any question? Okay, please write it down in order to continue. And for those who finished writing, please think about the answer. We have polynomial and exponential at infinity. Which one is stronger? It is the infinity that's coming from the exponential, it will be the answer. And if the 0 comes from the exponential, it will be the answer. Okay? Let's look here. What's the answer? We got this one as negative t over s, e minus st, minus 1 over s squared, e minus st. This one, t tends to infinity, minus add 0, we will get 0 minus 1 over s squared e power 0. Right, Miss? Is that the way that we evaluate? Now this one, it's 0. It's clear that it's 0, right? 1 over s squared times e power negative infinity is. Now this one, Miss, as t tends to infinity, we will get from this one 0. But from t, we will get infinity. Infinity times 0 is indeterminate. But again, this one is what the 0, it comes from the exponential or from the polynomial? From the exponential. So which one is stronger? So we will get 0 minus 0, and here minus 1 over s squared. So what's the final answer? 1 over s squared. Okay, Miss? I will go back to this one. So what do we reduce now? T under Laplace transform, it goes to what? 1 over s. writing from the board, please find the class of e power 3t. E power 3t, we need to find the Laplace transform. We can do it each two patterns. E power 3t. Find now the class of e power 3t. Instead of f of t, what will we put as? E power 3t. So the first step, e power 3t, 0 to infinity, e minus st dt. E power alpha dot e power beta, this one is equal to 1 minus. Oh, so we need to apply this one. Please let me know if I can write it in this way. What should they say? Negative. Okay, what's the integral of this one again? Negative 1 over minus 3, right? E power negative t minus 3 between what? 0 and infinity. Do we agree, miss? Minus 3 is constant. Evaluate it at infinity, what would we get? The limit at infinity. E power negative infinity means 0 minus at 0 we will get 1. So it will be the answer 1 over s minus 3. Minus and minus something. So from this, what did we deduce? E power 3t under Laplace transform becomes 1 over s minus 3. Any questions before we proceed, miss? Now, if we have a function, we don't have to find its Laplace transform.
0.
0. E power negative infinity. You evaluate it or you find the limit at e has to infinity. So e power negative infinity is key. Any questions, ma'am? Do we have any question? Let's find one more using integration and then talk about the formulas. Can we think about this exercise? If you look at this function, it's given as piecewise defined function. Between 0 and 3, it's given as something, and greater than 3, it's given as something. We need to find its Laplace transform.
Laplace transform for the both from 0 and 2.
Both of them are one function. So if you want to sketch this function, it is 0 to here. And this is the function that we want to find. So it's one function, but we say piecewise because it's defined over intervals. So the first step, just write the formula. What's the formula? Laplace of t is equal to 0 to infinity of t e minus t, and t, what do we have? dt. The first step is okay for all customers. Now, Smile is saying, but f of t has two values. How will I handle this problem? These two values, they are over different intervals, right, Miss?
From 0 to
So how can I divide this integral? After I did the same, that I will put it from 0 to 2 or 3, what do you think? 0 to 3 plus from 3 to infinity. Why did I choose 3 and not 4?
because of the both.
If we are giving it from 0 to 5, I will choose 5. 0 to 2, I will choose 2. Now, and here, e minus st dt, and here also e minus st dt. Function between 0 and 3, what's the value for it? 0, perfect. And the function after 3, what's the value for it?
2.
Upper integral of 0 is what? So this one is what, Miss? 0, right?
Yes.
So still we need to evaluate which part, Miss? The last part. Suppose that I'm dividing it over 3 intervals. How many integrals do I expect to have? 3 integrals. Please continue with now, Miss. What will be the answer now, Miss? Please continue. We need to integrate now. So the Laplace is Laplace of e equal, we said 3 to infinity to e minus st et, right, Miss? Because the first one is 0. We took just the second one. What's the integral of the second one? 2 is a constant, right? The 2 stays the same. E power negative st, it stays e power negative st, and we should divide by negative f between 3 and infinity. So we will get negative 2 over half infinity. Then at 3. Again, I'm not evaluating at infinity. This is limitless. This one is what? 0. So what will be the answer? E minus 3s over s. Do we have questions now? We need to fully understand the Laplace because after the Laplace, we talk about the inverse Laplace. Any question? Did we finish writing from the board? Now we have some formulas that we can use them immediately. Already we learned how to find them, but these formulas we can use them immediately. If we have a constant, it will be constant over x. Let's say I'm telling you find the Laplace of 7. Immediately you would write it as 7 over x. Okay? If you have t power n, if you still remember t, we got 1 over s squared. T power n is n factorial over s n plus 1. What do you mean by n factorial? Miss 0 factorial is equal 1 factorial equal to 1. 2 factorial is equal to 2. 3 factorial, you are doing exactly this. You are multiplying all integers, all positive integers that they are less than 10, so it's 6. In general, n factorial, what you are doing is 1 times 2 times 3 till you reach what? Okay? So this is what we mean by factorial. So Laplace of t power n, please write it as n factorial over s. This you can write it as a table. So the constant, Laplace of it is constant over s. T power n is n factorial over s n plus 1. Please write it because we will apply it now. Laplace of e power at, it's not the same one, any constant. Constant is constant over s. Laplace of e power at is 1 over s minus a. These formulas, we need to memorize them. So the constant, it's easy to memorize the constant over s. E power at also, it's easy, 1 over s minus a. We solve like it. E power n factorial over s n plus 1. Now sine k, k over s squared plus k squared. Whereas to sine kt, it's the same, but instead of putting kt, k in the numerator, we are putting s.
We will choose the hyperbolic function.
Now, if you look at the hyperbolic sign, it's the same as the sign, but instead of having in the denominator plus, what do we have? Minus. And the cosine is the same as cosine, but again, instead of having in the denominator plus, what do we have? Minus. It's easier for you if you put it as table.
You want A from the calculus too.
We will give direct examples on all of these in order to be able to understand them and memorize them in class. Yes, Laplace, it reminds us of the integral. So if I'm giving you Laplace of f plus g, what do you think the answer will be? Perfect, the same as integral. What if I'm telling you Laplace of constant times f? This constant, we'll put it outside the Laplace. Do we have a question? Thomas, Laplace of f plus g is the same as Laplace of f plus Laplace of g. And if we have Laplace of a constant times f, this constant will put it outside. Again, same, these properties are inherited from the integrals because Laplace transform is an integral transform. Do we have any questions? Before we proceed. Okay, just to make sure that we will apply first what's written on the table, and then we will mix them together. So the first one I need to do is to find Laplace of T3. We need also to find Laplace of e power negative in T. Let's start with these ones. Let's go to the notes or the table that you sketched and link it to this one. This rules are given these. The tables of or the rules of the class will not be given in the exam, so you have to practice in order to memorize them. Okay. Laplace of dq, which formula should we apply? So this one is what here. What will be factorial, 3 factorial over x, and 1 which is 3 plus 1. Shall we go to the rules and link them together? Are you able to see the answer in this way?
Yes.
Is it clear for all of us? Of course, we will not keep it in this way, so we'll write the answer as this over as those. Please check the rule for the second one. When we have exponential,
This is A
what's A here, Abdulaziz?
minus A.
So this is A, right? What would we get? 1 over x minus A. So what will we get this?
That's plus 8.
1 over s. Questions before I proceed? Start with these sentences. Think about these ones. One, it reminds us of what miss. What's K here? So it is K over S square plus K square. So we will get 3 over square plus 9. Let's go back to the rules. In order to memorize, we have to practice, miss. Do the second one. What's mine? What's our K here, miss? So it is S over S square plus K square, which is S over S square plus 49. Is it clear, miss? Then we need to apply the shine and shine. Okay, start with these ones, compare them to the rules about shine and shine. Remember, the shine is the same as sine, but instead of plus, we have minus and we didn't need. Similarly, because shine is the same as cosine, but we have negative and didn't need. What's our K here? So it is K over minus K square, which is 9 over S square minus 8. For the shine, what's K? To shine T, K is
1.
so it is over S
Good.
square minus K square. So S over S square minus 1. Is it clear enough?
Yes.
Any questions before we proceed? Now do these ones. When we have to plus between them, what can we do? Separate. So separate them. So plus 1 plus 5t, the first one. So it's the plus of the first plus. So this one is equal to what? Laplace of the first plus 5 Laplace of t. Right, miss? What's Laplace of 1? 1 over s. And Laplace of t power 1. It means that n factorial over x power n plus 1. Is it clear, miss? Abdurrahman? Clear? The second one, it is Laplace of sine 3t minus Laplace of 1 plus Laplace of cosine. Laplace of sine 3t is equal to what? Square cosine and 1. Okay, and cosine
1 s
1 or s
1
over a square minus. Any questions now? Do we have any questions? Yes, Ahmed, do you have a question? Ahmed and Abu Zaid. Yes.
When will it use this?
Whenever you have these ones, always go for the formula. The only way that we don't go for the formula is when you have piecewise defined function. Piecewise defined function, you need to integrate. Because of that, I started integrating just to refresh our minds about integrating. So when we have this one, these ones, they don't follow a formula. So we have to integrate, okay? But otherwise, if I have sine or cosine, I will just put them using the table. Now look at this one. Is it on the table? That you put it in this way. Is it on the table? We have we can, what should we do first? Expand. So in this case, I cannot solve it from the table. I should expand. How do we expand the Laplace of? Okay, let's write the formula here also. We don't have space here, so it's okay. We can write it here. So much. A plus B squared is equal to A squared plus 2AB plus B squared. So this one is Laplace of 9 plus 3 times 2, 16 plus T squared. Do we agree with this? Now can we separate? Can we separate? How many separations should we have now? It's Laplace of 9 plus 6 Laplace of T plus Laplace of T squared. Right, miss? Okay, please continue it now. Okay, so what's Laplace of 9? 9 is a constant, so 9 over s. Laplace of t,
6 plus
1 over s square multiplied by 6, and Laplace of t square is 2 over
is
s. So 2 factorial over s2 plus 1, and this will be our final answer. Do we have any questions, miss? Till now, we do not know how will we apply this one to differential equation. We are just having function, finding their Laplace transform. So what we are done, if we go back to our main objectives for today, or what we will do is that we were done with the Laplace transform. We need now to talk about the inverse Laplace transform. What do we mean by this? So any questions regarding Laplace transform, miss? Do we have any questions? You can check. Do these ones. We can do as well with this. We can do this one. We can practice in these ones, and we can do these ones as well. Any questions before we start with inverse Laplace? I need for you to go again to the table that you sketched about Laplace transform. So let's say that we have pi. Under Laplace transform, it goes to pi over s. Now pi over s, if we want to find its inverse, we will go back to pi. Which one will be applied here? Inverse Laplace transform. So here we are applying Laplace, and here we are applying Laplace inverse. So if Laplace of 1 is 1 over s, Laplace inverse of 1 over s, it will be what?
1.
1. So what do you mean by Laplace inverse? I have a function, I'm sending it to something. Laplace inverse of the new one, it will be the original 1. Okay, miss? So if we look at Laplace of 1 is 1 over s. What will be Laplace inverse of 1 over s? 1. Laplace of t is 1 over s squared. So what's Laplace inverse of 1 over s squared? T. Laplace of e negative 3t is 1 over s plus 3. So Laplace inverse of 1 over s plus 3 is e negative 3. Now we need to construct the table for Laplace inverse. Laplace, we are okay with it. We'll construct the table. Now these two tables that we will have, they will remind us of the derivatives and the adjectives. Okay, miss? The idea of Laplace inverse, are you okay with it? Before we proceed. Here just it's an illustration of the Laplace inverse. Now, here the same table that you had, they just removed the Laplace and put on the other side of Laplace inverse. We will write it in another way. So we will write these formulas. Here we have f of s, and here we will have s of t, which is basically the class members of f. Start with constant over s. This is the first one. The second one, we will write 1 over s minus a. The second one, we will write 1 over s n. This one. So this is the first one. This is the second. This is not right now. I will keep it. Now, the fourth, we will write 1 over s squared plus t squared. Let's stop a little bit at these ones and then we'll continue the other ones. The first one, what's the thing that will apply and get k over s? It's what?
Okay.
K. Laplace of k is k over s. Is it clear? The second one, 1 over s minus a. Go to your table. Which one, the Laplace of it is 1 over s minus a? E power
Okay.
80, or if we have k, we'll put e power k. 1 over xn plus 1. Which one looks like this shape?
T.
Yes, t power,
T power.
t power. But the t power and what's the Laplace of it? N factorial. So how can I need n factorial here? So what should I do here? I will divide. Okay? Miss, in the derivative, we multiply by something. When we need something up in the derivative, in the integral, it will be when up. So I will put it up. This one, it reminds us of what?
That's fine.
Okay, the cosine, it has s up. Here, what do we have? Constant. So constant reminds us of the sine or of the cosine. So this one basically should be sine kt. But in sine kt, what do we have? K over, right? Do I have a k here? So what should I do? Define this.
Can it be also? It's fine. Can be cosine, but divided by.
No, you cannot divide by this. As if you are dividing by a variable in the integral. Just constants we divide. Please write them down, miss. We still have 3 more functions to add. We will continue now with the table, okay? So we will write again here s over squared plus k squared. We will write 1 over squared minus k squared. So this is number 5, number 6, and number 7. And here s over squared minus k squared. Please try to fill these ones as well. final exam, we have 2 hours. So when you start the exam, you can write the formulas for hill class, for hill class. Please link it to the other table. Okay. Square plus k squared, it looks like what? Cosine or sine? Cosine 80. Should I divide by something?
No.
I have that. Now this one, square minus k squared, and a constant here, it reminds us of sine what? H kt. But in sine h kt, we have k up. So what should we put here? 1 over k. This one, it reminds us of cosine kt, and we don't divide because we have s up. Please write the table, go again through it, so that we can start with direct application on it, and then we start increasing the levels of the inverse sum. Did we finish writing from the coordinates? Okay. Let's put our own examples. These are solved. So let's start with our own ones. Please start with these ones, compare them to the tables that you have. One over 6. What do we have here? 6. And this 6 is what? 5 plus 1. So it's 1 according to the table. 1 over 5 factorial. And what do we have here? T power 5. Any questions regarding the first one? In the second one, this one is what? Minus. And this one is 9, right? So this one, what does it mean? K is equal to 3.
So it's sine.
We have 1 up. It means that negative, it means that sine h or cosine h. Up is constant, it means that it is sine h. Here we have 9, we will take its radical, so sine 3t. Constant, it means that we will divide by this constant. Is it clearness? Any questions? If you think about this one, which formula we should apply? If we have A plus B over C, this one is equal to what? We started this one. Do it. During this time, I will take attendance. How can we write this one? Can we write it as Laplace of 3 over square root 2 minus Laplace inverse of 2s over s squared plus 2? Can we write it in this way? This 3 that is here, can I put it outside? And this 2 that is here, we can put it outside, right? Okay, miss. Continue it now. The first one, 3 squared plus 2. What came here, miss? Radical. So we will get 1 radical, 2 sine or cosine. Second one, cosine. Here, did all of us get these answers, miss? We have a similar example here. Any questions before we proceed, Miss? Do we have questions before we proceed? Done right on the board. Let's think about this one. I had a question, I think for a while about it, how can we solve it?
That's cute.
No. Yeah, but in meter, we do not have the right to spread. The method to spread now. We took it in calculus too.
Option.
Partial fraction. So in numerator, we can separate them. They are under addition or subtraction. We don't have the right to separate. So whenever we have such a question, there is multiplication. The s alone in the denominator is perfect. I don't have problem in it. S square minus 9 also we don't have problem in it. And S plus 3 we don't have problem in it. But when they are multiplied together, we do have the problem. So we need to separate them. Whenever we have this one, we should use partial fraction. It's explained in detail there. We will go briefly on that. Okay, so let's write this one down. Plus 2 over s into s squared minus 9 into s plus 1. A squared minus b squared is equal to 1. A minus b into A plus B. So what will be get? S plus 2 over, please not show, S into S minus 3, S plus 3. Miss, can we change just this 3? I wanted another value. Let's put it as 5 here. Just go to the question and put it as 6. Put this one as 6. This one as plus 3. So first of all, we factorized. We wrote the denominator in factors. Now, this one using partial fraction, these factors are linear, right? Linear, the factors are the order one, right? So we will put S here, S minus 3, here, S plus 3, and here, S plus 6. Okay? And here we will put constant, another constant, and another constant. Again, this one was explained in detail in our solving session when you can go through it, or you can go through calculus 2, the part about partial fraction. So I would write this one instead of rewriting it each time. I will give it the letter M. Any questions so far? What's our aim to find? A, B, C, and D. But look at this one. Are we able to evaluate the plus inverse of this one? Do we have problem in 1 over s? Do we have problem in 1 over s minus 3? 1 over s plus 3, 1 over s plus 6. So all of these we know they're in inverse Laplace. Only we need to find constants A, B, C, and D. Now, what I usually prefer to do is to find the plus inverse in terms of A, B, C, D first, and then evaluate these. Okay. But now I will teach you how to find A, B, C, D in an easy way. How do you usually find it?
S equals 3, S equals
Yes, so have it side. Okay. So we need to find a's. Because these factors are different or distinct, you will hide the s from here and the s from here. Hide. Okay. When we hide the s from here and s from here, what are we left with? S plus 2 over, hide it in front of you, miss, and give me the answer. What will we get? We will get this one when we hide, right, miss? When we are hiding the s, miss, what are we left with? What makes this denominator here 0? S equals 0. So you will evaluate this one at S equal to 0. What will we get now? 2 over negative 3 and 6. So we will get 1 over or negative 1 over 27. So A is negative 1 over 27. Please do not try this. For B, what should we find? Okay, what are we left with if we are higher? If we hide it, if we hit S minus 3,
S plus 3 S plus 3.
S plus 2 over S plus 3, S, and here what do we have? S plus 3. Okay, when we hide in B, this denominator, what makes it 0? S minus 3, what makes it 0? So we will evaluate this one at what, miss? At S equal. What will we get now? 5 into 3, 6, and 9. We will put the answer. Please give me the answer for this one. 9 times 18. What will we get? 100. Oh, so we got B equal 160. Okay. Just before we continue. C, how can we find it? What should we hide? S plus 3. What are we left with? And where should we evaluate it? Minus. Perfect. Did you write this one? Okay. Please write these ones. And this method, we call it heaviside cover-up method. Write it down and continue finding C and C. Heaviside cover-up method. It's written here because it's not a heaviside method. HEAVI side method. Please write A and B and continue finding C and D to make sure that everything is okay. Could not do exam 1 or exam 2 other than Abdulaziz and Loeb.
It is two or something.
Because I'll just put the example from one way. So after we finish A and B writing them from the board, please find C and D. Okay, so for Siemens, what should we cover? We should cover S plus 3, right? So C, cover S plus 3, it means that we evaluate at negative. We are left with S minus 3, and S plus 6. And up we have S plus, evaluate what will we get? Negative 3 plus 2 over negative 3, negative 3, negative 3, and here we will get, so negative 1 over 3 times 3, 9, 54 we will get. So negative 1 over 56. Finally, the D we should cover. What should we cover for D? Plus 6. So for D, cover S plus 6, it means that we evaluate it at S negative 6 plus 2 S into S minus 3 S plus 3. The answer for this one is?
Two or 28.
2 over 28. 81.
Yes.
Okay, and you got 4 over 162. Same one. Okay. Okay, so we found A, B, C. But the question is not about finding A, B, C, D. What was the question? Find Laplace inverse, right? So we found these ones. Now when Laplace inverse of F, it would be Laplace inverse A, what was it? Negative 1 over 27, Laplace inverse of 1 over S. B, it was 5 over 162, so 5 over 162, Laplace inverse of 1 over S minus 3. C, it was negative 154, Laplace inverse of 1 over S plus 3. And the last one, it was plus 2 over 81, Laplace inverse 1 over S plus. Can we write it in this way, miss?
Yes.
Now, each of these, do we know the Laplace of each of them, miss? 1 over S, Laplace inverse of what?
1.
So we look at negative 1 over 27, 1 over S, it's Laplace inverse L, 1. 5 over 162. 1 over x minus 3, it becomes e power 3t, right? And over x plus 3, it becomes e power negative 3t. And over x plus 6, it becomes e power negative 6. Do we have any questions so far? Yes. Now, what I need from you to do is take around 3 minutes, go back again to the table of Laplace, inverse, the methods that we solve to make sure that everything is okay. If everything is okay, we can continue. Questions? Let's go back to the formula. Here we have another example using the plot of the reverse fusion partial fraction. We can do practice and this one. We're done with the Laplace transform, which is using the formula at reminds of the derivatives. And then we talked about the inverse Laplace transform, which reminds us of the integral and with the formulas for that. We said that if we have a fraction addition between them or subtraction, we can separate the numerator. The denominator we cannot separate them. What should we use to separate? Partial fraction. And we solve some examples. The only thing that we need now is why are we learning Laplace transform? We said that our course is differential equation, so the aim of anything new that we learn is just to help us to solve differential equation. So the method that we will apply now is apply Laplace transform for differential equation. But in differential equations, what do we have? Usually, at least we have either y prime, first order, second order, third. So we need to link the Laplace transform to the derivative before we apply it. So here we have the general formula of the derivative. Please do not write it this way. I will explain it as simple as possible. Let's say that we are getting Laplace of y. We are finding a function, giving it as capital of y. Why did I choose y? Let's say because if we have a differential equation, we have y, we have y prime, we have y double prime, we have y prime s. Laplace of y, it's capital Y. Our aim is to find Laplace of y prime, Laplace of y double prime, say, and say. Now, first of all, Laplace transform, in order to apply it, we should have an initial value problem that is needed. Okay? So if it's not an initial value problem, I cannot apply Laplace transform. Now, does it make sense that to have initial value problem in real life, we don't have differential equation like alone without initial value problem? Why? Because we are modeling something. Modeling something means that we have the initial value and we know the initial value. So either we have it as initial value or what do we have it? Boundary value. So in real life, this one, it's okay. We can find it. And usually 1t greater than 0. Also, it makes sense because most of the differential equation, I'm not saying all. Most of them, the independent variable is time. Time usually greater than 0. So the time that I start my experiment, I can choose it as t equals 0 and I make it at any time. So t tends to infinity. Okay, miss? We're starting with Laplace of small y is capital Y. This Laplace of y prime, it will be applied the formula. Its derivative is 1. So we will put as y minus y0. This is y that difference. So we will start with x squared y minus y0 minus y prime. If you have second derivative, how many conditions do we have? How many initial conditions should we have? Y at 0 and y prime at x. Let's deduce the plus of y triple prime. It should be, what do we have triple prime? So SQ1, then start decreasing. Where y0 decreasing as y prime 0 and here minus y. Okay, miss? So we start decreasing the s. What we are doing exactly, Miss, I will return to this one. We are applying this formula. So if we have an derivative, start decreasing the s and increasing the f. Okay? Please write these ones down. What if we have y fourth prime? We would start with s for y minus s cube, then s squared, then s, then nothing. Please write it down, Miss. Again, whenever we are solving a differential equation using the class, be it this slide, it should be in front of us, plus the Laplace transform, it should be in front of us, the formulas, and the inverse Laplace also, it should be in front of us.
And this one's not clear, and this is one way.
And these small y's, we can find them from where? From the initial value problem that we have. Before we proceed, done writing from the board? Now again, our main objective is to solve an initial value problem using Laplace transform. How will we do that? We are given the initial value problem. First step, apply Laplace transform. When we apply Laplace transform, the y prime, it becomes in terms of capital Y. Now y of 0 is a constant, right? The y double prime, it becomes, instead of that, what do we have? Capital Y and constants. So basically, do we still have derivatives when we are applying the Laplace transform? What are we getting? A variable, capital Y, and we are getting Sn, right? So we will get just an equation in Y and S. If I'm telling you 3 capital Y equal to F, or 3 capital Y is 1 over S, can we find capital Y? So the next step, find this Y in terms of S. Okay? So first of all, we apply the Laplace transform. We are having here y prime, and so on. Here, do we have y and y prime? What do we have only? Y and function in what? In S. So we will write capital Y in terms of S explicitly. Capital Y equals something else. But again, when we want to solve an initial value problem at the very end, what's our aim? Find what? Y. Find small y. I don't want capital Y. What we did miss here is that Y, we apply Laplace transform for it to get what? Capital Y. I got capital Y. What do I need? So what should we apply? Laplace. So after finding capital Y, what should we apply? The inverse of Laplace to get small. Okay, miss? Just write the logic or the algorithm of this method. I re-explain it again through an example. So the first step, apply Laplace transform. Then write capital Y in terms of S only, then apply the Laplace inverse, and we are done. So we will try to solve this one. Five Y prime plus 4Y equal to 2, and Y of 0 equal to 1. So what was the order of this initial value problem? How many initial conditions do we have? One, which is enough, right? Okay, so how do we solve? Number one, what do we need? Apply Laplace transform. And we will write Laplace of Y instead of at each time writing Laplace of Y, we'll put Laplace of Y equal capital. Please stop writing. I will explain this steps. We will solve lots of examples hopefully next lecture, but we need now just to understand this. So Laplace both sides, it means that Laplace, the left-hand side, equal Laplace of the right-hand side. First step, is it okay? This one, can we write 5 Laplace of Y prime plus 4 Laplace of 1 equal Laplace of 2 from the table? 2 over X, right? This Laplace of Y, what will we write instead of it? So we will get 4 capital Y here 2 over X. Laplace of Y prime equal to what? Sy minus y2, right? So we will write Sy minus y as capital. Right, miss? The first step, are you okay with it? Okay, miss. Simplify it, rewrite it again. What will we get? We will get 5xy minus 5 times 1 is y0. It's 5 plus 4y equal 2 over x. Let the y together. 5x plus 4 and 2 over x plus 5, right? Question till now? Okay, what do we need, miss? Y only. We need y only. Bring this one to the other side. Okay, miss? So we will get, this one we can write it as 2 plus 5x over x, right? So we will get 2 plus 5x over x into 5x plus 4. Now we are done with step number 1 and step number 3. We found capital Y. What's our aim? Find small y. Okay, miss? So let's go back again to the steps. This was our question. We need to apply the Laplace transform. So what's the first step, miss? Right, instead of Laplace small y, capital Y, then the first step, what do we say? Apply Laplace for both sides. So Laplace of the left-hand side equal Laplace of the right-hand side. Are you okay with that? We have addition and scalar multiplication, so it will be 5 Laplace of y prime equal plus 4 Laplace of y equal 2 over x. Why 2 over x? This one, from where did we get it? From the table of Laplace. Now, Laplace of y prime is equal to what? We got it from the slide book, Peter. And y0, do we have it, miss? And this one for capital Y equal 2 over s. Substitute instead of y0 its value, so we will get 5 sy minus 1, which is 5 sy minus 5, right? Do we have questions so far, miss? We got now 5 sy minus 5 plus 4y equal to 2 over s. Everything in y on a side and everything not in y on another side. So we can take the y in common here. We are left with 5s plus 4 and bring this 5 to the other side. We can simplify it, write it as one fraction. And then this one that is here, miss, we need to bring it to the other side. We will get capital Y equal to 2 plus 5s over s into 5s. What do we need now? We got y. How can we get yt? What should we apply? Apply. So this is step number 3. This is step number 2. Apply Laplace inverse to both sides. Do we have any questions now? Hopefully on Thursday, we will solve different examples on Laplace transform. And we will discuss also when you remember Laplace transform, which is translation. Any questions for today, miss? We are done, miss. I just saved it and shared it with you on Teams. Remember, miss, that we have a homework that is due on Sunday, I think, about the series, and a homework that is due the week after it about the Laplace transform. Have a nice day, miss.
Thank you.
What happened? Thank you.
Yeah.